So number 3, you're being asked to, oh, I'll freeze it for you. It says name the molecule, right? Given the name of the molecule, write the correct molecular formula. We don't make you go the other way. If you're a chemist, obviously you're going to have to be able to look at a formula and know what the name is. But the reality is for what we're doing this year, you're going to be given word statements that you have to be able to write into correct balanced equations. And that's what chapter 9 is about, is the next step where we put all this into a balanced equation. So you just have to be able to go the one direction. And covalent compounds are really easy because they tell you the formula. You just look for the prefixes, and the prefixes are pretty easy. The only one that tends to give people trouble is di means 2 instead of bi. Di and bi are both the same. And then tetra, but think tetras. Tetras you put in groups of 4. Otherwise, they're pretty common. Hexa and hepta, you just have to remember hexa is 6, hepta is 7. Hepta, don't they use septa in math? I see that a lot anyway. So hepta is very similar to that. So now when you look at this, you see the prefixes. It's telling me 2 nitrogen, and then hydrate is hydrogen, 4 hydrogen. That's all I do. And 2H4. So I'm just going to pause a second here and let you try the others that I've got up here on my example. But it's really that simple to write equations, or to write covalent formulas. Okay, so if we look back at these, nitrogen, dinitrogen tetrahydride into, oh, I'm frozen. This job looks a lot easier than it is. I just want you to know that. Into H4, what'd you come up with for iodine pentafluoride? Yeah, IF5. You notice we didn't put monoiodine. Mono you don't have to put on the first one because a lot of compounds are mono whatever. So then if you alphabetized compounds, you'd have like 800 mono somethings. So then the alphabetical list isn't really helping you. Dihydrogen monoxide, H2O, that's its technical chemical name. Carbon tetrachloride, CCl4, and then nitrogen trifluoride, NF3. If you had to do it with a polyatomic ion, we're not going to expect you to know the acid naming rules. So if it showed up, which I don't think they do, but just in case, if I gave you like hydrogen phosphate, when you see the ATE, that's your hint that it's not just phosphorus, because if it was phosphorus, we call it phosphide, IDE. So you go look on your polyatomic table, and you see you have hydrogen and PO4, but PO4 by itself is a -3. How many electrons can hydrogen share? Just 1, right? It can share a total of 2, but it only has 1 to contribute. So if phosphate needs 3 total, I know this is going to have to be H3PO4. That's the only thing a little bit tricky with them. If it was sulfate, SO4, I look SO4 up and I see it's -2, so it'd be H2SO4. If it was carbonate, CO3, oh, CO3 is still a -2. If it was chlorate, ClO3, that's a -1, so just be HClO3.